Looks like we're missing quite a few people, so let's wait a few more minutes. Usually we get more than this, so. Okay, well, I guess we'll go ahead and get started. Everything's streaming okay. Perfect. Only 3 today? Okay. So let's just do a quick summary of where we are in the semester. Assignment number 4 is due this Friday. I don't know why I thought it was due today. So it's due Friday. I did see about 3 or 4 people already submitted it, so I'm guessing probably the 3 people in class today. Yeah. So for anybody watching at home, if you need help with this, we'll do one example today that might be somewhat helpful, but really watch last week's lecture because I really gave you everything you needed to solve that. And the basic idea with this assignment is that I give you a simple algorithm, and you have to go through the process of turning that algorithm into a function. So you have to have clearly defined inputs, a clearly defined output, and inside is that algorithm. Now, there are ways to do this with very little code. There's actually already built-in functions to essentially do this. Don't use all kinds of external functions. If you find yourself using the max function that's already provided, or no, this one's average. So there's certain functions I don't want you using. There's like a function to add up all the numbers, sum. I don't want you using that. Stick to the algorithm actually used in class. If you find yourself using external functions that we haven't talked about or going to other websites, you're going down the wrong path. Everything that you needed to solve that problem was given in that lecture. Okay. We're going to do the midterm in 2 weeks. I was a little bit apprehensive about doing this, but because we're in such a strange situation this semester, what I decided to do was make this exam a take-home exam, but you have a very short window, so you'll only have 48 hours to complete the exam. And I guess it'll be from the start of class. So I guess from the start of class, or maybe I'll release it at the end of class so people aren't working on it during class. Maybe that's a better idea. But I'll time it at 48 hours. Please let me know if this is going to be like an impossible task because of work or other classes or anything like that. I think for most people, when I do the exam in class, you would only have about an hour anyway. So you just really need to find about an hour at home to complete this exam. I think for most people, you can find an hour in a 48-hour window, but we'll see how that goes. So just let me know ahead of time if you foresee this being an issue. And this is 2 weeks out that maybe you can plan a little bit and make some room in your schedule to make sure that you can sit down in a quiet area and complete this exam. I'll give more details about it next week. I don't want to burn through a bunch of class time today talking about it. Okay, so you've got this assignment due. I didn't do an assignment 5 this week. I'm thinking that I'll assign that next week. Because realistically, I think we're going to get to about 8 assignments. And schedule-wise, we're doing all right. So we'll have 5, 6, 7, 8. We'll have the last 4. The second half of the semester. And that works out. So this is week number 7. I think the schedule we're on is going to work pretty well. So any questions about administrative stuff or scheduling or anything like that? So let's do this. And then one last thing. I don't know if I made an announcement in class or anything, but I did this last Friday. I got a couple people connected. I'll send an announcement. I may or may not do it again this Friday. I'm leaning toward actually people emailing me and then trying to set up sessions and I can group them all together rather than just sitting around waiting for calls. But a long time ago, back in March when we were first starting to deal with the pandemic, I wrote a video conferencing system essentially where you share your screen, and it works better for our classes because most of the time you want to share your screen and then I walk you through the code. And the idea was that it's like when you call tech support, you don't really care who you're getting, you just want somebody helpful at the other end. And we have various tutors that are employed by the department. So the idea was whether you get a professor or a tutor, it doesn't really matter. It's just somebody that can help you with the class. In practice, what's happened is because everybody's so busy, usually what ends up happening is just the professor connects. But I still liked it because it forces you to share your screen. So there's a little video on that page if you want to watch it. But I may do that this Friday, or I may make you register ahead of time just to make sure that I'm not sitting around waiting for people that are never going to connect. So just keep an eye out for that if you need help. That's really only if you need help. Okay, let's get right into it. So let's open up a new REPL. So let's one more time go through that process of taking a very simple algorithm and then turning that algorithm into a usable function with very clearly defined inputs and very clearly defined outputs. So I don't think we've done an example where we've done an algorithm for finding positive numbers, have we? That's a very, very simple algorithm. It's just essentially an if statement. And so let's say we've got some list of numbers. And at the same time, I want to also do some review with lists and dictionaries as we go through this. Okay, so let's say, for example, I have some numbers here. So just as a reminder, is this large enough for everybody? I'll go one more. Is this good? One more? Okay, that's good. So I've got this list of numbers. Remember, there's 2 ways to define a list, and same thing with dictionary, is that we can define it up front, which is what we've done here, or if we wanted to modify an existing list, So I'm going to erase this so you don't have to type it, but I can do numbers.append. So this is defining it up front. This is if I want to dynamically append to a list. And notice that we see our original list here, but then we also see the -9. But for right now, we'll just use the version where we define the list up front. And this is very simple. So to loop over a list, it's not like in C where we have that 3-part thing. This is what's really known as a for each loop. And so we say usually for each item in the list. We don't actually use the word each. Some languages do, but here we just say for the individual thing. So here we're going to say for the number in the list of numbers. And then let's just say print number. And just as a quick review, remember a list is a collection of things. In this case, I'm using numbers, but it could be strings. It could be other what are called objects. It could be, we can have a collection of dictionaries if we wanted to. But in this case, we'll keep it very simple. It's just a list of things.
Isn't this list technically string? Or is it actually like?
It is actually and actually an int. So if we were to print the type, just to be sure, we'd see a bunch of ints. Now, had we gotten it from user input, had the user typed it in, it would have been a list of strings. That would have been correct. Now, don't forget, just as a quick side note, we can always use that square bracket notation if we want to get an individual element. So numbers, plural, 0, that would print this. If we did numbers 2, it would go 0, 1, 2. Okay. Now in practice, in Python, we don't actually use that square bracket notation that often for lists. Usually we're more concerned with looping over it. But every once in a while we might. If we want to get the very first item or the very last item, sometimes we do that. So here what we're doing is, for each number in the list of numbers, let's go through, and each time through it assigns it. And you can see that here. 1, 4, 11, -2, 0. And the idea for this program is to only count the positive numbers. So we're going to say if number is greater than 0, and I guess depending on your definition, let's get rid of 0 here because that's a little bit unclear. Let's say -5. So 1, 4, 11, -2, -5. So if the number is greater than 0, let's print the number. So the only positive numbers here were 1, 4, and 11. These two were not positive. So everyone's very clear with this very, very simple algorithm, correct? Okay. So let's turn this into a function. To do that, remember, what's that? Exactly, yeah, so we write def. And remember, the whole purpose of a function is to have a modular, reusable piece of code where I can feed very clearly defined inputs and get a very clearly defined output, because we're not always going to be using this function in the same way. It's not always going to spit out a number to the user. Another part of the program might run it. It may not even have a keyboard or mouse. So let's do this. This one was, we'll just call it num, or how about this? Pos count. And so that'll give us the count of positive numbers. And then what we need to do is, remember, it's in blocks. So we can highlight this and hit tab, and that'll indent one level. Now remember, going back to C, this would be like the curly braces like this. Okay, but we don't do that in Python. What we do is instead we use this colon, which means that we're doing a block of code. Anything indented, notice that we have this indentation level here. Anything indented here is a part of that function. Same thing with our for loop and our if statement. They're all indented. If you mess up that indentation, don't think this will run. I always say just use one tab. The indentation rules are very complicated on what it accepts, but it's very easy to mess up, so I just do a tab, and that'll expand it out to whatever it needs to be. So we run the program, nothing happened. Why? Well, we've defined the function, but we haven't actually used it in our code. So up here, when it defines the function, it's almost like having a blueprint, but then it doesn't do anything with that blueprint. Having a blueprint of a car is not the same thing as having a car. So here we have to actually call the function. And it gives us the number of positive numbers. So it's a function, kind of, and it works. But we always want to define, or we want to worry about design and engineering. Just because something works doesn't mean it's a great way to do that. Okay? Does anybody see, so let's go back to our definition of a function. It has very clearly defined inputs and very clearly defined outputs. Would you say that this is a, even though it is a function, is it a good function?
No.
No. So what's the most, so there's a few things. Just start naming off problems one at a time, and we'll discuss them. What's the biggest problem you see?
The fact that it can't do anything with 0.
What's that?
The fact that it can't do anything with 0.
Oh, if it's 0 exactly?
Yeah.
That's less of a problem, because what we could do is something like this if we wanted to. But let's not worry about that. Go think just in terms of the definition of a function.
Well, it doesn't really do anything to it. It doesn't change it at all.
So let's go back. Let's say, does it have very clearly defined inputs? If I were to put a box in front of you with this positive count, what would you feed it as inputs?
Positive numbers?
And are we really doing that?
No.
No. Because where do we put that? Right here. So what's happened is we've hard-coded the numbers. And that's very bad design. Why is that bad design? Because it's very often the case that what you do is you take this function and you package it up and put it in some file that a person's never going to read. Okay, it's very common that other people are writing the functions that you use. And to be able to use that function, if it were written like this, that would mean you'd have to go find that file amongst thousands or tens of thousands of different files. You'd have to go inside there and modify it. And then it's like it's no longer dynamic. Each program is going to have to modify. So it kind of defeats the purpose. So we want to have very clearly defined inputs. And so what we'll do is we're going to say that the input is going to be numbers. And we don't want that here. We're going to say, so you have to kind of have two mindsets right now. Is that here we have our function. Get rid of some of the extra space. And then here is our, what we'll say, user code. So let's pretend somebody else wrote this. And then this is a second person calling this function.
Oh, okay.
Does that make sense? So imagine this is in some file far away that we can't get to. This is better because we're saying, okay, take in these numbers, and then down here I'm saying, okay, here's some numbers. There's this issue of scoping that I don't want to get into right now. So what we're going to do is let's rename this. We'll just say, these are all integers, so we'll just say ints. Scoping is a little bit complicated. I don't want to get into it right this second. We probably will today. It's an important topic. So this is much more clear, is that somebody else has made this box, and they're saying, okay, when you want to use this thing, you're going to have to give me some numbers. And it's sort of up to us to know that the numbers should be a list. A lot of times we accomplish this with comments. Unfortunately, the difference between C-based languages and Python is a C-based language would let you know ahead of time, hey, this has to be a list. This is all I'll accept. With Python, unfortunately, we're just saying it's called numbers. So we might have to put a comment or some other documentation way to let us know, but we can worry about that later. So we solved one problem. We've said, okay, we've got a very clearly defined input. And here we're passing it. So here's our blueprint. No code actually runs yet. Then we say, okay, we're going to have some integers. And here's our list of ints. And then we're going to pass these to our function, which will then run this very simple algorithm. It'll go through each number, and then if each number is positive, it'll print that number.
This also opens you up to taking input from the user.
Exactly, yeah. So that solves half the problem. We have a very clearly defined input, but then the other problem is, do we have a very clearly defined output?
Well, it just spits out numbers.
Exactly, and this is where people get confused. The print statement is not the same thing as an output.
Right.
Why? Imagine if you're writing a video game, and for some reason you've got a bunch of numbers in that game, who cares why, and the game itself does some calculation based on those numbers. If you're playing like a racing game, would you want a bunch of positive numbers just popping up on the screen somewhere? That'd be kind of a silly function. What you want to do is many times you write your function for other functions to call it, or other programs, or we want it to be, again, this definition, we want to be very clear. We've got inputs and outputs. And the only way that it makes it proper and modular is if we use it like that, because then we don't care if a video game is calling this function, or if it's being used in the car's fuel injection system, or if the operating system is calling it. We don't really care who, because we've been very clear on it takes in a list of numbers, and then it returns the number of positive numbers. So what we want to do instead is that we want to start off assuming that we don't have any positive numbers. So we'll say the result, maybe we'll call it count. I usually like to use the term result because it's very generic, but really we're counting something. So we'll say count is equal to 0. And then rather than printing the number, every time we reach a positive number, we're going to say count is equal to the old count plus 1, which I think we also discussed. I like to write it the longhand way in the programming classes because it really tells us what we're doing. Is that we're saying normally our code runs top to bottom, left to right. Some of the exceptions are when we have this equal sign, it actually looks at the right-hand side of the equal sign. And so the first time through, it would say, okay, the initial count was at 0. I do 0 plus 1, and then store it over here, so the new count is 1. The next time through, count was 1, and it'd say, okay, 1 plus 1 is equal to 2, store it over here. Now, there is a shorthand, because that's such a common operation, that most of the time we just tend to do count plus equals 1. Now, I'm fairly certain Python, for the longest time it has it, maybe they added it, but I'm pretty sure we can't just do count plus plus. Yeah, you can see that's going to generate an error. That's like mostly a philosophical thing that they, for whatever reason, that they felt that it breaks some good programming rules or whatever. It doesn't really matter. But so we don't have the plus plus like you've probably seen in the past, but we do have the plus equals. So this is most common, is that we'll say plus equals 1, which basically says increment the count by 1. Now we're not there yet. We have to do one more thing. We were calculating how many positive numbers there are, but we're not doing anything with that. If we were to look at our box, on one side of the box we have a very clearly defined input. This is the magic that happens in the middle of the box, but if we looked on the other side, there wouldn't be anything to output. How do we output that? With that special keyword, return. And return says, okay, I'm going to give you the thing. I don't really care. It's up to the programmer to give you, but this return keyword is what actually makes that happen. And we're going to return count. This is a much better version because, again, has very clearly defined inputs and outputs, and it doesn't matter if I'm using it. It doesn't really actually matter where, because I'm not dependent on there being a keyboard present. I'm not dependent on the programmer changing code inside of the code. This is like a magic box that I would never actually have to look at the internals of this. I could use this function anywhere and it would run properly. Now we're almost there. It actually does run, but we're not doing anything with the stuff on the other side. It's like it returns a result, but it's like we're not there to catch it. It's just kind of falling on the ground after it returns the number. So what we can do is we can say result is equal to, and then rather than just letting it fall on the ground, we're doing something with it. We're grabbing it and saying, okay, now we've got that result, and let's just say print result. So it's saying that there are 3 positive numbers, which looking at this, it does. Sometimes it's a little bit difficult. You have to use your imagination because even though we are writing these functions in the same file, this is a rarity. Usually what you're doing is using functions that are way off in some other file that you'll never actually look at. And the idea is that you shouldn't have to. If somebody describes this magic box as being able to count the number of positive numbers, you don't care what magic happens on the inside. You just know that you feed it some numbers and it gives you how many of those are positive. So this is the example I want you to have in your notes. I'm going to do one more example, which drives me crazy, but I see this in various places. So again, don't type this because it's just like a throwaway example. It's just like something I don't want you to do. So again, don't modify your code. And you might think, oh, this is great. We've actually got an interactive version now. And it returned 2. What's the new problem that I've introduced here? Going back to the definition that I've got clearly defined inputs and clearly defined outputs. What I've done is I've essentially made this function dependent on having a keyboard to type this in, that the input's going to come from the user. I violated that clearly defined input rule because I'm just basically saying I'm depending on my data from somewhere else, and that's not good. So I don't know if I went through this example or not, but basically the idea is that we don't want to have these print and input statements scattered throughout our functions or writing to files or anything like that, because what happens is over time there are things that don't change and there are things that do. User interfaces change all the time. So if we think just since the 90s we went from green screen terminals to in the 90s we had the web. After that, we had mobile apps. And imagine if you're writing an accounting program, the basics of accounting over that time probably aren't changing, maybe tax law and stuff like that. Or if you're running a bank, the idea of deposits and withdrawals aren't changing. But if you've wrapped up a bunch of input and output statements inside of your function, you've made it that your code is dependent on the user interface. Okay, so that's why I really always suggest against using input and output statements of any sort inside of the function, is that if we want to get it from the user, what we want to do is in another area outside of the function, gather up all the numbers, because then we can still do what we need to do, get the numbers from the user. And then now we have to pass this in. And even though the final effect may be the exact same that we, from our perspective, this is organized much better, because if I change from a website to an app, I can still use this function exactly as is. So this function would last 100 years because it's not in any way dependent on what's called input and output. And so very broadly, input and output would be your keyboard and mouse, the screen that you're printing it to, because again, you might not even have a screen. What else? Network, right? Reading, writing from the network, reading, writing from databases, reading, writing from files. Now you might think, are there exceptions to this? And there are. The exception is when the whole purpose of the function is to either gather input or produce output. And so you might have a function to do this thing right here that you might want to call get numbers or get input or something like that. Then it's okay, because the whole purpose of the function is just to get input. And you know ahead of time, if I ever rewrite this for a different user interface, I'm going to have to throw this function away. It's not going to be terribly useful. Okay? And so it's nice to kind of organize your code. And I just went over that example just because I see this all the time, people throwing in print, and especially in the C++ class, C in and C out statements inside of the function. That really violates the whole core reason for the function, is that you don't want to, you want to be able to move this function around pretty much anywhere and not have to modify it at all. Okay. Any question on functions? Okay. You don't really have to have this example in your notes. This is really the one I want you to have in your notes. And this example really closely aligns with the assignment. Really, to do the assignment, you could have just used the lecture from last week, but this was just another example to kind of help you out. There's this idea of scoping, but I'm going to hold that off until next week. Scoping is very important, but I don't want to throw too much at you in one class. So I think what I'll do is I'll wait until next week to talk about scoping. Okay. So let's just do kind of a quick review summary. Just make sure everyone's super solid on lists and dictionaries. We're doing pretty good on time in the class anyway, so this would be a good point in the course to just make sure everyone's good and you've got a solid foundation, because everything after this, it's going to build on top of those basic things that we've done so far. Okay, so let's start a new REPL. So as we've already seen, is that we can define a list ahead of time. So we can do that. Usually we kind of want to space these out a little bit. I guess I shouldn't get into the notion that these all have to be unique. They don't. So I can have 3 twice in here if I need to. Now, as we already saw, I can append to an existing list. So I can do numbers. Maybe I should comment these. To, let's say, an existing list. You can see here was the original list. Here's where it was appended. Now, just like arrays in C, I can get an individual element of that list. And so what's this going to print here? So we go 0, 1, 2, 3. Remember that it's 0 based. So what's it going to print?
9.
It's just going to print the 9. Now, one thing that we really didn't talk about was there are alternative ways. So let's so you'll see this. I don't think that you have to do this in any assignments, but we can actually, if we want to look from the right-hand side, we can actually count backwards. So this would be -1, -2, -3. So what we can actually do is we can, the reason this is convenient is because there are many times where we just want to get the last element in a list. And so all we have to do is say, okay, -1. We don't have to do all kinds of calculations to see how long the list is and then get it from there. It's just very simple. We just say -1. So this is a very common thing. And notice that because we appended it, 11, this became the new last item in the list. Now the other thing that we can do is we can say I is equal to 3. Num is equal to numbers I. Remember that we can replace these with, we don't actually always have to have a like a hard-coded number. It can be a variable. So here we are printing numbers 3, but here we said I is equal to 3, and then in square brackets did numbers I. And that gave us the same result. Maybe I don't want to move things around. These two might have been better grouped together, but I don't want to change it now. And then finally, something that we didn't really talk about, there's this idea of slicing, that we can actually get multiple things. Slicing is used a lot, but I try not to make the course overly advanced, but it is kind of a common thing. I don't think you have any specific homework assignments using slicing, but it is very useful. So what I can do is I can say slice is equal, that's not a good name. Say nums. And so I can say start from offset 1, so that'll be 0, 1, and then end at 3. So 0, 1, 2, but not including 3. So this one should just print 3, 2. Oops, sorry, nums. Notice that it returned it as a list. So this is like a subset of the list. We call it a slice. So again, the syntax is that we wanted to 0, 1, so at position number 1 up to, so 0, 1, 2, 3, but not including 3. Same thing here if we had extended it. So it'd be 0, 1, 2, 3, but not including 4. So it should go 3, 2, 9. And so slicing is very common as well. Yes?
Is there a way to append a number to a certain spot in the list? So rather than just adding it on at the end?
Probably, but to be perfectly honest, I can't really think of cases where I've done it to where I know it off of memory. My guess would be what I would probably do is slice it, and then what you can do is very easily concatenate. So let's do that. So this might not be the best way to do this. There's probably something built in, but what we can do is we can we'll just say more slicing. So say for example we want part 1 to be numbers 0 through 2. So this would give us 5 and 3. Part 2 we want it to be numbers 2 Now here's another little nice shortcut. We could count these up and say 0, 1, 2, 3. But actually, if we just leave this blank, it assumes that we want it to the end. So here we'll see part 1, that'll give us 5, 3. Part 2, that'll give us everything else, so that'll give us 2, 9, 3, 11. And what we can actually do is we can actually use the addition. So again, this is kind of advanced, but what we can do if we can say P1 plus whatever we want to put in there. Let's say a couple more numbers. Plus part 2. This is basically its concatenation. And so we get part 1, which is 5 and 3. We get our other elements, 132, 937, and then you see the rest of the list here. There might be something built in directly into lists, like where you can do it as a single line, but this just, I guess, gave us a chance to show list concatenation.
I can't really think of anywhere where you use that too much, but I was just curious.
There are reasons to do it and exist, but I'm guessing it's a rare enough thing that I would probably look it up if I had to do it in code. It's not one of those things I remember off the top of my head, but it is. I don't want to say never occurring. It is something that occurs, every once in a while. Okay, and then finally, let's just make sure we know how to loop through these things. So there's two ways. There's the most common way, which is going to just be for number in numbers, print number, and that'll just give us one number at a time. This is the most common. And that's what's going on here. Or we could do this another way. Almost nobody does it this way, but I just wanted to show you that it's possible. There's this function called range, which gives us a list of that numbers. It actually uses something called a generator, but it basically lets us range for that number. So if I did range 5, it would give me 0, 1, 2, 3, 4. So what I can do is I can say for I in range. Now I could hard code the numbers, but we like to use len where possible. And remember that we can use this square bracket notation. I guess it should be consistent. I'll say number. Hopefully you see the reason why it's not often used.
So much more syntax.
Yeah, it's just this is much cleaner. They accomplish the same thing, and I've often noticed that new Python programmers who are used to C will write it like this, but kind of the Python way of doing things would be just this version. Okay, so I think that's really all we're going to use in this class for lists. Just make sure you know all these things really, really well, because a lot of this, we're not going to really do much with like this level of slicing, but maybe we'll use a very simple slice. So make sure you know this. This is probably a little bit advanced. And I don't really care about you knowing this loop. Just know the basic loop, because that's what we're generally almost always going to use in the class.
Would list be a good name to call this, as like the whole page?
Yeah, like list summary or list review or something like that. I just want to make sure everyone's super solid on lists because we're doing pretty good on time. And I'm going to do the same thing with dictionaries. So we'll go through, make sure everyone's super solid on dictionaries. So the idea of a list is that I've got something ordered. So what I mean is when we define this like had some order to it. And I could say, okay, give me numbers 0. And so it was index based. With a dictionary is what we call a key value pair. And hopefully you remember from before, like our phone book, is that you might have the person's name and then their phone number. We're not really defining it in any sort of ordered way like this. We're saying that Alice has this phone number, Bob has this phone number, Charles has this phone number. Okay, so let's do the same process for dictionaries. And I guess we'll go with the phone book example. That one works pretty well. So what you can do if you want is up front you can define an empty dictionary, which is very common. But let's do this just so you have some practice. You can actually define things at the time of creating your dictionary. So let's say, for example, our dictionary is just a phone or a person's name pointing to their number. So let's say we'll use all lowercase. Alice is at 555. So the idea is that we know that it's a list if it's square brackets. We know that it's a tuple, which is very similar to a list, if it's the parentheses. And the dictionary, we know it's a dictionary by these curly braces. And so here, remember, we're dealing with key value pairs. So in this case, the key is Alice, and the value is Alice's phone number. Same thing with Bob and the phone number. If I want to add an additional entry into the dictionary, all I have to do is put a key that doesn't exist, and it'll automatically add it. So if I want to add Charles, all I have to do is say, okay, this is what Charles equals. And if we want to, we can also change an entry in the dictionary. So say, for example, Bob's number changes. We can say, okay, phone book Bob if all of a sudden Bob's phone number changes, it's just as simple as that. So we don't have to jump through a bunch of hoops and specialized functions. Adding and changing just kind of magically happen.
For a minute there, I was scared I was going back to sleep.
Why is that?
The curly braces.
Oh, yeah. By the way, this is one of the few times that you can split up Python code over multiple lines, and it's generally okay with it. Because imagine if you had to put this all in one line, it would be not very readable. So this is one of the few times that you can do this. Most of the time, you generally can't. Usually, it'll yell at you and say, "I don't know what you're doing." And let's just go ahead and print our phone book. And we should see Alice with Alice's original phone number, Bob with Bob's new phone number, remember, because we changed it, and then Charles, who we added with this 555-3333. Now, it's not uncommon to loop over an existing dictionary. Let's do this. We'll say for key. Because remember, it's key value pairs. So that gives us the key, but what if we wanted the phone numbers? Well, we could just say print phone book and based on the key. So this will give us the key, and this will actually look up their phone number in the phone book based on that key, just like we did before. So here it's saying, okay, Alice is at this phone number, Bob's at this phone number, Charles is at this phone number. So we're not stuck just having very simple key value pairs. In general, we do want to keep the keys simple because they actually have to be what's known as immutable, essentially read-only. And strings are great because strings are read-only. This name Bob is never going to change. Once it's Bob, if it changes, then it's a different name. You know, so this works out really well. On the value side, we can actually get kind of complicated with these. Okay, so let's, is everyone good with this example?
Yeah.
And then I post the code if anybody still needs to type anything. Yeah, so we're recording too, so you can always pause it. So let's go to a new REPL, and let's do a slightly more complicated phone book. And I think this will be the last example we do today. That's a good cutoff point. And today's class really served as a good review. That way, when we move forward, maybe we'll do an example of tuples just to make sure everyone's good with tuples as well. And then going forward, we call these data structures, and we'll start to in the future use these data structures to do more interesting programs. So let's say, for example, our new phone book is going to be more complicated. It's still going to be the person's name, but then the value might be their we'll just say phone, short for phone number. Okay, and so let me take a step back. So it's going to be Alice, and Alice is not going to just point to a phone number anymore. Alice is actually going to point to a dictionary. So we can have dictionaries inside of dictionaries like this. And then the idea is that, okay, Alice is going to have a phone number and an email. So this is cool because before we just assume that Alice is going to point to a phone number, but now we're pointing to a dictionary. So now we can hold more information. Let's also do the same thing for Bob. So if we wanted to get somebody's, let's say, email from the phone book, maybe we should have called it directory, but we already called it phone book. So we would say phone book, their name in square brackets, and then the thing we're trying to retrieve. In this case, because remember, this is going to return a dictionary, and then we want to retrieve the thing from the dictionary. So in this case, we want to get their email. Now we could wrap this whole thing in a print, but let's just say email equals so notice if we were to look at this, it would say, okay, go to Alice, and what does Alice return? Alice doesn't return directly a phone number like before. It returns a dictionary. And then from that dictionary, we say, okay, get the email, which then directly returns a string, which we can easily print.
So this is how they build like profiles.
Exactly, yeah. This actually leads into a subject is when you deal with various APIs like the Facebook API and Twitter and stuff like that, they give you a format that's called JSON, and it almost identically mimics this format. What's great is when you're writing Python code to deal with these APIs, you get that JSON data format. You don't have to really almost do any formatting. It'll put it into Python code exactly for you because it works so nice and neatly. A lot of languages don't do that. Like if you were to try to parse it out to C# code, it doesn't really. You can get it to do it, and a lot, sometimes you have to, but it's not nearly this clean where it matches into the language. So let's do this. I'm just going to comment this out. Let's do an interactive version where we say, so they can do a lookup in the existing phone book. So we can say, so enter the name of the person that you're trying to look up. And I guess we'll call it mode. What mode are you trying to get a hold of them? So this is either going to be phone or email. It's probably not a great variable name, but we'll just say mode. So it'd be the mode of communication. And then what we can do is let's do this. We'll say result is equal to phone book. So we're going to first look up in square brackets their name, which they provided as a string, and then the mode. And then from there we can print the result. Yes? That's actually exact. Yeah, that's a very good point. Yeah. So one quick thing, you don't have to do this if you don't want to, but I don't know if everybody heard. In general, what you want to do is when you're dealing with things like names and stuff like that, you want to make it case insensitive. So what you could actually do is, and just to illustrate your point, is that if we entered in Alice like this, it's not going to know about Alice because Alice is all lowercase. So what we can do is do this. After we've gotten the input, we can call this, is it lowercase or just lower? I think it's lower. We'll find out. Yeah, it forces it to all lowercase. So no matter what they type in, it's going to force it to lowercase, which is what we have stored. But you don't have to have this if you don't want to, but that's a good point. We'll actually probably do a more complicated version of this next class. I kind of want to build up on this one at a time, because what we can do, somebody might have multiple phone numbers, or multiple addresses or multiple emails. So we could take this even one step further and make it a list. So we can have a dictionary that points to another dictionary that points to a list of values of all their known addresses or something like that. So
back to the JSON thing real quick. Is that a Java-based language?
So it stands for JavaScript Object Notation. And what happened was in the early days, when you wanted to send data across the web, the most common way to do that, it's actually valid JavaScript. And what people did was, because it was such an easy descriptive format versus this other format called XML, which you might have heard of.
Yeah.
XML is very, very verbose. It's not super easy to read. Versus JSON is generally somewhat human readable. You can kind of see what they're trying to communicate. And so that kind of became much more popular, kind of became the data format of the web. And it's actually just plain old JavaScript. It's actually valid JavaScript. So
it was JavaScript what notation?
JavaScript Object Notation, JSON. So let's very briefly talk about tuples and the whole purpose of a tuple, and I guess that's a good stopping point. So we've talked about lists. The idea of a list is a ordered collection of things. A dictionary isn't really ordered. You can actually, if you want to, you can make it ordered, like you can alphabetize it, but by default there's no guaranteeing of the ordering. It's just kind of luck if it happens to be the same order. Sort of close to a list is this idea of a tuple. So let's do one more here. And to me, always the easiest to describe a tuple is using GPS coordinates. And I think we've already done this example, but we'll do it one more time just to have it. And tuples are read-only. They're what's known as immutable, which is kind of nice because we can actually use them as in dictionaries. Remember I told you that it had to be read-only for the key. But there are other kind of nice uses. So for example, we had GPS coordinates. And I'm not going to put in real GPS coordinates. So this is a tuple. This has 2 entries, but if we wanted to, we could have more entries if we were describing like a 3D coordinate or something like that. And the way we typically use, so first of all, we'll just do a print. And so you might think, okay, this looks an awful lot like, well, so if we wanted to get the individual element in a tuple, we could do just like that notation that we do for lists. So coords 1, so this would be coordinate 0 and 1. So you might think, why even do this? Well, the nice thing is that it's read-only. It's what we call immutable, which means that we can use it for other interesting things later. So if I try to do this, so if I try to change that coordinate, I'm going to get an error. It's going to say it's immutable. Yeah, it doesn't support assignment. So it's like we define it up front. Now you might think, because this kind of looks so much like a list, that you'd want to use it like a list, but very often we don't. What we do is we use it sort of like a dictionary. Imagine a dictionary that just had a coordinate, latitude and longitude, but it's much sort of lighter weight than a dictionary, and it's just kind of easy to use. Is that it's you can say, okay, 0 is latitude, 1 is longitude. It's very common that we would actually have a list of tuples. So let's comment this out. And let's have an empty list. So let's say we'll call points. So it might be points on a map. And let's make that an empty list. And what we'll do is we'll ask the user for 3 points. So we'll say for I in range of 3. Remember how this works is that this will go through and loop through 3 times, 0, 1, 2, so 3 items. And what we'll do is we'll say, okay, ask the user for a latitude. Ask them for a longitude. And then what we'll do is we'll make one of these coordinates and then we'll append it to our list of points. So what we've got going on here is that we're asking the user for a latitude and longitude. We're converting that into a tuple. We're storing it here as coordinate, but it's a tuple of a latitude and longitude, and then we're going to append it to our list of points. This is very, very common. It's to keep a list of tuples. And then we can say print points, and then we'll see here that it's going to be a list. So I'm just going to enter in dummy numbers. Notice here that we have a list, because the square brackets, of individual tuples. So here's our first point, here's our second point, and here's our third point. Probably should have converted those into like a float or something, but you get the basic idea. Okay, so I think next class what I want to do is talk about scoping inside of functions. We're going to start to do some more complex examples using these various data structures like dictionaries and lists and start to combine them together a little bit more. And then for your assignment, you're basically going to be doing something like writing a phone book. But so there's no new assignment this week. Just make sure to get the current assignment complete. And then next week we'll talk about the new assignment, okay? And we'll also talk about the exam, okay? Yeah.
Is scoping that thing where inside of a function that variable is active, but once it goes outside of the function, you can still reuse that variable?
So that's called global scope. We'll talk about that. But the basic idea is that when you put a variable inside of a function, it's scoped to that function, so it's not valid anywhere outside of that function. And the whole reason for that is imagine a large program that's like, say, 100,000 lines of code. If you could never reuse variable names again, you'd run out really quick. Generic names like I, J, K, A, B, X, Y, result, count, things like that. So there's probably other reasons, but that's one of the main reasons is that the other is so that you have clearly defined inputs and outputs. But yeah, so we'll talk about that more next class, though. What's that?
I think you touched on it last class.
Okay. I actually have an example where I show you the ID and show you it's actually, even though it's the same name, it's actually at different memory locations. But I thought that might be a little bit too much to try to squeeze in today. So we'll do that next class, though. Okay. So I think that's pretty much it for this class. So no new assignment. Just make sure you get your other assignment complete.